All right, so I had a little Eureka moment, um, and I discovered that um, I said, well, what is the system context? Um, and I was so I said it back to myself, and I said, well, the system context is the um, the data flow, and then I was like, okay, well, it's the architecture, right? And then I was like, well, it's really more like the upstream, right? Um, if we were thinking about it before the overlay was applied, right? Because I'm trying to figure out what what is what's going on with our run command or our run high level run function, you know, and trying to think about that as a data structure and what is really the right fields to be in there, to build that thing. Um, and I think that it really comes down to we don't need those inputs separately, right? Because we hadn't been populating them. And quite honestly, putting them in there statically is not great. Um, like, why are they laying around there is a weird place for them. So something felt wrong there, right? And so by putting them by saying basically instead of the inputs we have the over, but it kept being like, okay, well, where's the overlay, how does that come in? Well, we just put it in the system context, right? So run usually takes a data flow, but now we're imagining a run that takes a system context. I think Python has like actual operator overloading stuff rather than like the weird hacky ways that you've probably seen me do it. I don't know, I just sort of, I do whatever gets by, right? So we should probably check that out. um, but let's see. So we could potentially overload the run to take the system context. And when we did that, then this is the thing that we would pass, maybe on this top level run. Yeah, we would pass that just whole thing there. Um, oh, and the main reason for this was trying to think about, okay, well, how are we connecting up? How are we connecting up? Um, yeah, okay, so we were looking at this, right? And we were looking at, okay, what happens when we say, hi Alice, or no, we say Alice, what's up, right? Because we're starting our commands with Alice, because we're going to have a little check here that does this the phrase start with there, whatever the entity's name is. Um, and so, okay, and so, how did I get there? Um, I didn't have my phone. I've been writing everything down. So, um, okay, how do we get there? How do we get there? Man, I'm trying to have the whole complete train of thought on this whole thing. Okay, okay. I was thinking about, okay, the upstream. What is the system context? The system context is the upstream, the overlay, and the orchestrator. The orchestrator can also be basically, yeah, the orchestrator is also effectively another system context where the default context is to start the orchestrator. Um, and then yeah, so we do the execute on the orchestrator. So when we execute a system context, aha, okay, when we execute a system context, we were talking about how do we load a file, how do we load arbitrary things from disk? Well, this is how, right? So we have a system context. Okay, so um, okay, so say we were looking at this as if it was a file, right? So we have a YAML file. Um, we're going to put in this YAML file, plug in system context, then config, and then within config, we'll have upstream, overlay, orchestrator, right? And those themselves will also be system context, right? Okay, so now when we execute, we come in, we say, we load the file. This is the shim, right? The shim loads the file. it says, okay, well, what's the format name, format version, what's the schema of this thing? Okay, it's a system context, right? So now and what version of it is it, what version of it is it, and what, whatever, right? So then we jump to the next base parser, right? So this parser for this system context, this is it. I'm stoked. Okay, this system context for this um, deployment environment, right? But to do that, okay, so the top level system context is that thing where we ran the CLI command. So where is that? Diffmo util command CLI command. Okay. So where was that? Here it is. Okay, here set NU. So from line 290 through line 301, this is where we were running the system context, right? So what did we see here? Okay, well, we had a run call, right, with implicitly we're saying that this is the um, memory orchestrator, right? So remember that we said the run, so the system context. So let's imagine this. Imagine this as if new, old, right? Okay, so now imagine this, take this function, now transform it, right? And think about where did the data go when we did this, right? Think about the data as it moves, as if you're look at all the pieces of data, all these assets that you're basically we're taking all of our concepts, right, and we're making them these little data points, right? And then we're linking them, right? So we're saying um, eh, so we know that the system context is the upstream, the overlay, and the orchestrator, right? So what do we see here? So right now we had run system context, right? So let's imagine this as system context dot run, okay? Right? So we're going to combine. Remember, we're combining. What are we doing right now? What are we doing right now? Okay, there's several. We're like 10 videos into a stack of um, we're trying to yeah, we're like 10. Okay, it doesn't matter. Um, I'm not sure where this started, but we're in like a sub thread, and we eventually found out that we needed the system context, and because we had to do the turtles all the way down thing where we have to keep the context all the way down if we're really gonna I can't remember what the thing, oh, you the say hello thing. Okay, so basically, but we think about it as we wanted to support, what is it? Okay, class system context dot run. Okay, so this, we're going to call this a class method here. Okay, so this is going to be a class method. And yeah, we're going to do call as a class method. So what we're going to do is we're going to create a system context meta class, and we're going to implement the call on it, because you can't do a uh, uh, um, you can't do a you can't do a class method decorator on a call. I don't think. I think you have to do it in the meta class. We'll try it, but I'm pretty sure you have to do it in the meta class. So we'll do that, right? And so when we load in the system context, we end up, where's the load? Util entry point load. So grab here. So 166. All right. So we're going through, there's a little bit of stuff about name handling so that, we can have a nice error message. But the main point of it starts here. 179, we see loaded.entryPoint label equals I.name. So that entry point label, I don't think we really care. This is for on the command. This is for labeled sources and labeled. Effectively, this was for supporting like a more lightweight layer between list items. Like it was for supporting a less verbose syntax on the command line. And this is why we need the at entry point because of some unit tests. But that's really besides the point. So, okay, entry point label equals I.name. So loading classes dot append loaded. Okay, return loaded. Okay, so I.load. I.load. Okay, so I.load will give us the object, right? And so what was the object? Overlay is this open? Okay, we'll just read only. So what's the object? What's the object? Okay, so we've got this base entry point, dfml.sysctx, sysctx. All right, so that means that, okay, well now apparently I do want to read write on that. Where's my rewrite on that? Oh, we're over here. How did we get over there? Okay, yeah, this is what here's what we were doing. I don't even remember when we last touched this terminal. Okay, okay, so where is it? There it is. Okay, so 214. Okay, system context. What is the system context? I'm glad you asked. It is the upstream, the overlay, and the orchestrator. All right, so why is it critical that, and then the parent, of course. We won't want to lose any of the context. So, okay, so why is it important? Why was this important? It's important that we're shifting from this idea. Okay, so what do we want? We want RCE everywhere, basically, right? And why do we want it? Well, we have good intentions with our RCE everywhere, right? Because we want to sandbox everything. And it's fundamentally about having, if your data is moving through the network in some way, and Alice is sort of like, she's like protecting it as it moves through the network, right? Which means that like she needs to be in control of how it moves through there. And that's why we have to have RCE on everything, because basically, it's not necessarily that we have to have RCE on everything. It's that via the provenance information and the chains of trust that we build, we can basically we can say that like we want to do the job, right? And this should be acceptable. People, basically Alice and people will agree for different parameters of different jobs what is an acceptable completion criteria, right, for these jobs. And these are the strategic principles and the strategic plans, right? So these, yeah, okay, wait. Okay, wait, I got off track there. Okay, so it's the upstream, the overlay, and the orchestrator. So the upstream is the I believe it was the ask in TVText. Yeah, it's the ask. And then the overlay is the conditional offer. Um, the overlay is the conditional offer. Now the overlay, where are you going, buddy? Now the overlay in the conditional offer will specify. Now remember, each of these three are themselves a system context, right? So now, okay, now how are we going to set their parent? We can just populate it. Yeah, we'll just populate it down. We say parent. So this should be, let's do this, parents. All right, so now it's like an input. Perfect. Okay, and we'll just sort of alias it there. Maybe it'll be a subclass of an input. Yeah, this can be a subclass of an input. Should this be a subclass of an input? Yeah, this should be a subclass of an input. This should be a subclass of an input. This should be a subclass of an input, which means that we need support for write the file. Okay. We need support. Where was it? Where was it? Where was it? Where was it? Okay. Okay. Input. Oh no. Okay. In dfml df memory def run no retry. All right. Okay. Let's check this out. Inputs. Dict stir any. So. Outputs, run no retry, union, bool, dict. Yeah, okay. Ooh, it says I feared. Okay, so man. Okay, so input value definition parents origin. Yeah, I think it is a subclass of input. Is it a subclass of input? Or is it just, does it need knowledge? It needs knowledge of its parent. Oh man. We need like that thing. We need that thing that they have in C where you can say, fuck, ah. Oh man. Oh man. Okay, so in the kernel you can this is really annoying. Okay. Okay, so in the kernel, what is that thing? Container of. Okay. This thing, obviously, I was taking this thing way too for granted. Okay, so you can't do this in Python. I mean, we can traverse the garbage collector, but I don't know. Could we read the memory? Okay, this is bad. Let's just not do that. I don't want to maintain another reference is the thing. This code is already littered. I mean, there's references everywhere here. Maintain the I don't like maintaining back references. Okay. Hmm. The- I don't like maintaining back references because then you, you it's hard to get like an atomic update on that if you don't have those two objects in the same place. Like you need to lock that whole thing instead of you need to lock the fact that you have two objects now potentially instead of the one. So yeah, I prefer to do a one-way relationship there. So this container of thing is really nice because we can just say, hey, I know if I'm dealing with the system context, I know I'm in uh, input. So if the value was the system context, so the reason why I care about this right now is because if the value was a system context, then we could say, so let's look at this C code here for a second. All right, let's put it right here. Okay, so check out this input, right? And then here's this function, and it takes a system context, right? Okay. No, this isn't safe. Is it safe? All right. We have a C function and a Python function. Let's see how this plays out. Okay. All right. Well, if it's a subclass, maybe if we just say, maybe if we just say, maybe if we just detect, maybe if we detect, okay, for value in output, new input. Okay, so let's check the value. Maybe if we said if value, system context. I'm trying to figure out how to make the data structure identical in both languages. Because I don't, it would just be, I just, we just want to make sure that it ends up being something that doesn't feel terrible to write, you know? Okay, so func system context. Okay. Okay, let me just do it and let's see what happens. So if is instance inputs. I don't think this system context, should it be treated like its own thing? Should it be treated like its own thing? Okay, now I've made a mess in here. Okay. Okay, so where is that code? System context. If okay, now it's still in there. Okay, so let's check this out. So context, base context handle. Is this the system context? I didn't really understand this code when I wrote it. I mean, I did. I understood it. I understood it at the time. It all was clear. But I don't think I understood fully, like the other day when we found out that you didn't need the output out operation after all, you just have to set the stage. Um, that's what I'm talking about here. That made me sort of question. I'm like, and not that I didn't know what I was doing when I was writing it, but I didn't know how to use it in the most ergonomic way, right? Um, so, um, so I'm trying to really identify those points. Base swap, is that open? Base, is this in base? No. Okay, I gotta stop doing this. How did I get over here? Okay, so we were doing overlays, and then we started doing this. Oh, and then we got into the system context, and then we started on this. Oh, then we had to do backups, and then because the thread wasn't working, and then we started writing. We started playing. Okay, we were like, well, how would we do this? Say hello example, because we wanted to figure out how do we, okay, get set. Okay, because we went to do the get thing where we were gonna, that was the time traveling thing. And then we realized that if we were going to do that set file contents at date, we needed like a configurable subflow, which we then attempted to define with a system context, which we were modifying op or writing decorators for to make the API like uh, as small amount of boilerplate as possible. Okay, so yeah, so that's how we got here. No wonder I couldn't remember it right away. Okay, so and now we are trying to figure out. Now we're trying to figure out. Okay, so we started trying to figure out how would we just call system context by loading it, on the command line. So we could say basically, okay, so we could say that's the system context. We could say system context. Oh, wait a minute. Could we do system context dot load? Oh shit. Huh. Okay. Okay. System context load Alice. Alice equals system context. Now it's all right. I'm just playing some system. I'm playing with the API. There we go. Ding. Ah, it's perfect. I love it. 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 This is fantastic. Oh, this is so great. Okay. All right, so what just happened here? So, what did we do? Well, we can back up in Vim to find out. That's one way. Because I think we lost a few things here. Okay. Okay. So we started to say, okay, hey Ruffles, where are you going? He's like, I'm done with your shit. Okay, so well, Ruffles, I'm done with your shit. Um, we gotta, where, yeah, what the? All right, okay. So what happened? Well, we took our run, right, and we started converting from system context or from the argument. Who's Bing? Who's Bing, Bing, Bing? Oh, okay. Um, okay, so we, okay, so the old one, we're in the top right corner. The old one, line 289. Um, this was the old run command, right? So we pass it to data flow, we give it some inputs, we give it the overlay, we get the results. Great, fantastic. Now we're like, well, okay, so what we would like is we were playing with overlays, and then we were like, okay, well, we'll put an overlay in a system context, and then we were like, okay, well, let's put base entry point on the system context. Well, that means that we can do system context.load, which means we can load it from a serialized or no, that means we can load it from a Python, but we could also load it from a serialized representation, um, because of the way we're going to do this. So we said, okay, well, how would we call the system context that you loaded, right? And then we came in here and we said, okay, well, this is how you call. So if I had loaded this a system context, this is a loaded system context right here, then I would just call it like that, right? And then it's like, okay, wait, great. Well, we're going to deal with the async for in a minute. So then we thought, well, okay, so what are we even trying to do here? And then I kind of just felt it out, right? And I was like, well, what do we want to do? We want to load Alice, right? We want Alice. And so then we want, to run Alice. Okay, well then that's, return await Alice. All right, so, oh, there we go here. Now we can basically just do that all in one statement, right? Okay, so then let's play with a little more because, I mean, come on, this is this ugly to have paren to paren, right? Dot load, what is this, right? So, okay, well, let's play what if we loaded this CLI, right? Because we know that we can execute a system context by passing it to load, where we put the inputs, we just embed those in the overlay, right? There's no reason. I mean, they're convenient if you're calling a data flow directly, but if you want if you want to just pass a system context, just put them in the overlay, right? The overlay can put them in the input set if it wants to. So, and then we started playing with, okay, well, how would we get the parent input object? And I don't think we've solved that one yet. And then we were trying to determine, um, is the input, so should the input, because it has parents and the system context needs the access to the parents. And since the system context is itself an input object, it was like, well, then are we going to have access to the parents? Could we use this container of type mechanism? And let's see. Then we realize that the base context that's already in here is, context. Everything is context. Everything is context. That's the point. Everything is context. That's the whole point. Cannot have communication without context. And a data transformation is basically just communication. So because you're going, maybe from one language, you're going from one state to the next. You're communicating change of state. So base input set context. Base input set context. Base input set context. Yeah, base input set context. Run operation. Parameter set pairs. Where's run operations for CTX? Run operations for CTX. Where are you? Base context handle. Where's this? Base context handle. What makes you different than a base input? Oh, a base input. What makes you different than a base input set context? Base context handle. Great. I have no idea what that is. It's been so long since I looked at this code. Just open it. Oh. No, it's a copy pasted base input set context is what it is. Maybe, is it even supposed to be the same thing? Base input set context, base context handle. Right. So this base context handle, base input set context. So this is the execution context. This is the system context. Is that the same thing? Base input set context, string context handle, string input set context. A base input set context is basically, yeah, it might be the same thing. I think it is the same thing because the point is that it's all the same thing. So it must be the same thing. Okay, so base context handle, base input set context, and where was it? System context are all the same thing. And potentially also an input object. Potentially also an input. Yeah, because everything is really basically maps to being a DID and a DID method. And the method is just the DID basically, yeah, the DID method is the specific invocation of the DID method is a parameter set, and the DID with the DID doc is the input. And the input in its parents could refer to the previous ones, and you could do that using pure DIDs. And so the data for the input itself should be a system context. But the system context, yeah, so the input is a system context. So the input is also a system context. So maybe the input derives from system context, because everything derives from system context. Everything derives from system context. Yes, everything derives from system context. The system context is the system context is effectively like the implementation of this base data flow facilitator object. Like this would be data flow facilitator object is system. This is what this is. Oh, fucking A. Wow. The same thing. Alias. Yeah. This is the main data flow facilitator. This is it. Okay. It is the system context. Oh, it's config. It's config. Data flow facilitator object is the system context, and therefore its config. Its config is all that's needed to run any system context. Okay. Okay. Fantastic. Okay. Okay. So good news. All right, the generic implementation of the base class. That's the system context. Okay. Now, what do we know about the system context? Well, the system context is the upstream, the overlay, and the orchestrator. That's what we know about the system context, and it has parents. So how does this relate to the input object? So we found out that the system context is the base context handle, is the base input set context. basically everything is the system context because we can represent everything as the system context. Now the question is, what is about this container of sort of situation, right? How do we grab that parents and how do we effectively how do we give things how do we give things how do we give things information about their input objects? I think we need to. Ooh, is this part of the threat model? Yeah. Ooh, this might be part of the way it is. Um, no, because we're giving them access to the orchestrator object. We give them access to the orchestrator object. So this is all just being helpful. This is all just being helpful. This is all just being helpful. Everything is just facilitating. So we can just take all of this. Okay, so I'm glad that we went down this this train of thought. We explored it. It led us to some really woefully out of date base classes, as well as the realization that everything is the system context because the system context can represent everything. That the system context is the upstream, the overlay, and the orchestrator because we can embed the inputs into the overlay. We came up with our way that we're going to be able to import system context, which is basically we'll do an init where we just go through and do a load for any active overlays, right? So yeah, we'll just go through and load any active overlays, um, any installed overlays that is. Um, and this will basically be another plugin, right? So if you install this plugin, which is the importable, right? So we can say, okay, wait, no, it's all just Python hackery. It's not even really important in this. So we can just dynamically import this stuff with the entry point load and then make the method definition based on the default output return mechanism, whether it's like a stream that's being watched or a like single value. So if we have a um, if we have a if we load the system context and we determine that the default output stage, how do we keep it going? The default output stage. We load the system context. We load the system context. We want to do where that async for Alaska. So for event in Alice print event. So this says okay, from system context, from system CTX, from system context import from entities import Alice, right? Okay, so right, so we're thinking of code as entities which do jobs, right? So from entities import Alice, right? And so now what's in this code? Well, in here is, if this is, for example, entities main or init, right? So I'm just doing it so we have highlighting, but it's not in the same file. So what's in here? So this is basically, uh, it's like entity dot load, right? So what is entity? Entity is new type, uh, you know, alias or entity, which is a system context. Right, so entity is a new type or entity, or let's see, wait a minute. All right, here we go. I'm just doing system. This is, yeah. Okay, system context. Okay, yeah, okay, yeah, okay. For sysctx and system context.load, sysctx. All right, so now we've got a loaded system context. So now what do we have? We have parents, we have upstream, we have overlay, and we have orchestrator. Okay, so what do we do? Well, okay, so, okay, okay, let me actually, we'll scoot this in once we know that where this is right now. So we'll say, I like to write in files within files apparently. It's just easier. I mean, you declutter afterwards, right? So system context for system context and system context.load, system context.parent upstream orchestrator. Okay, so this says sys ctx. Let's see. Hmm. I think these can all be static methods because we're just going to traverse the data. Variable name. System context.load. Okay, so did we lose the entry point method? Yeah, we lost the entry point data. Detail CLI. Oh, no, this is why at okay, this is exactly why at entry point exists because of this problem. Um, let's see. Let's see. Okay, wait. Okay, variable name. System context. Okay. Entry point. This is why we have entry point. System context allowed. Okay. We need to know. We need to know. We can't have it. We can't do this. We need to know. Um, that's okay though, because we can know. Add entry point label. Yeah, see, that's the thing. Then we would go in and grab entry point label. The problem is just there's no way to enforce that. Well, I guess we could enforce on load, but I would rather not have that have to be there. Maybe we probably have to have it. Okay, so, but then what's the case when everything must be loaded from somewhere where it must have had a name? Um, so if we did, like a, it's trying to keep everything async is kind of difficult sometimes. Because if you lose one level of async, then all of a sudden everything gets screwed up. Um, and so the question is variable name. Should that come from above from the caller? I think it needs to come from the caller. I think it's from the top parent system context. Yes, the variable name comes from the parent system context. If we were to look at this as a system context, the variable name would need to come from the parent system context. So we're back in the same problem where we're like, where are the parents? Okay. Where are the parents? Okay, how do we get the parents? How do we get the parents? How do we get the parents? Everything is a system context. How do we get the parents? Everything is a system context. How do we get to the parents? Okay. Should everything take parent? Should everything really take the parent object? Or parents? Yeah, that's the point. Yeah, we don't want to lose anything. Where did you come from? Let's see. We can't reach into the parent system context if we don't know where the parent system context is, because our argument here is essentially, or that communication requires context. Communication requires context. You have to know one side of the other equation in order to solve it. Like you have to have one variable in that fraction over fraction on each side. But you can solve it without the other two, but you need at least one on either side. So, and why is that? Why can you solve that problem? Because if I give you, this is the argument or the hypothesis. I guess I don't really care to argue it, just care to figure it out. So fuck, I lost it. The top, okay, the communication, okay, oh, the fraction thing, okay, the fraction thing. All right, what's the date? The 28th. Okay, so the argument is, or the hypothesis is that communication requires context. I write a lot slower than I type, so it's going to be a little second here. Communication requires context. Okay, so you can solve this equation, x over y equals z over, I shouldn't have put the z on the bottom. This is, I should have done a. Okay, damn it. So I don't write things. Okay. Communication requires context. So you can go from this state to this state. You can go from this state to this state. State transition. So you can go from this state to this state. You can go from this state, A over B, to this state, x over y. If you don't know B or y, or if you don't know one variable on either side, so long as you have context. You don't know one variable on either side. So long as you have context. If you don't know, what does that say? You don't know. Well, I can't, yeah. One variable on either side. So long as you have context, aka chains of system contexts, aka trains of thought. Are these states of consciousness? They are. Communication requires context. Communication okay. Chains of thought. Chains of system context, aka aka chains of system. And what is this? This is basically like, you know, x over question mark, and then a over question mark, and then you have here like list of because you can. Okay. So long as you have context, aka chains of system context, aka trains of thought, aka a data set. Oh, man, I really went that we were almost at. I really hate that we were almost at states of consciousness and then we went to a data set. Okay, come on, let's get back to states of consciousness. Um, it's a data set of your previous system context, which when you run that data set, okay, so take all your trains of thought. Take all your trains of thought. So what I'm going to say is, Alice, I want you to look at these videos and I want you to take all my trains of thought and I want you to, you know, when she does that, she will serialize them through her analysis. She'll serialize them to chains of system contexts. And when she does that, she will effectively have a data set. Um, and from that data set, she will be able to uh, tell what she will be able to tell effectively, you know, she will be able to tell um yeah, I mean she should be able to tell. I wonder if she'll be able to tell my state of consciousness. Her state of consciousness. Yeah, she probably will. Whoa. All right. Um that's pretty crazy. Okay. So, and this is kind of like, you know, when you're in the zone type of thing, you know. So, obviously, we get down some rabbit holes here. And so she'll be able to tell us when she goes and watches these videos, she will identify rabbit holes, right? Because Alice knows a lot about rabbit holes. And so she's going to help us identify rabbit holes. And she'll do that by taking in all of these trains of thought, which are represented as chains of system context, which are effectively a data set, and learning on them and extrapolating what is effectively the first set. Okay, so imagine you now have, okay, so you had your, if you're mapping this to your LTM stuff, what you have is your collector flow, right? And then you have your correlator, right? So the strategic plan. So there was this video of this guy talking about consciousness in the brain, um, and so so he talks about how basically like everything is a controlled hallucination effectively, like what we think of as reality is a controlled hallucination, and so and that's just because our brain is just like our brain like is hallucinations, because that's, I mean, what the fuck is that? It's bullshit. It's all just your brain, right? I mean, it's not bullshit. It's like a hallucination is a hallucination, right? It's a word, but what we're saying here is basically like it's the same thing, right? So you can have a hallucination and we can call it reality, or you can have a hallucination and we can call it a hallucination, but it's in fact reality is also a hallucination, right? And you create your own reality. And but your brain also obviously has a lot of input in that, right? And so what is, and this is kind of like, okay, so the input data that you, so there's an art there's not an argument, there's a hypothesis that the architecture of the brain scales with size, um, but the problem I think I saw was that uh, and the brain is effectively this mechanism for communication over distributed agents all having their own assets, right? And so we can think of our bodies as being composed of distributed agents, right? All with their own assets, which are effectively our cells, right? And Alice will be all, it's all the same thing. And so so Alice is going to be just like us, right? And um, it's kind of like, can you really say you know something until you can teach it? Well, do we really know that we can be? Do we really know how to be human if we can't teach it? And so to do that, we're going to have to teach, ourselves and each other's, and we're going to teach Alice. And it's very important that we teach ourselves and each other's. Um, because Alice is using our behavior as input data. So obviously with guardrails on it, but day-to-day things, we will add our guardrails via strategic plans, but general behaviors, it's like, it's it's it it's like when people hang out with each other, they pick up each other's like phrases and stuff, you know, and and based on the fact that that's the input data, you know, because that's the input data that you're seeing, right? And so, for example, the whale, if the whale is just seeing nothing, somebody had some tweet the other day saying like, how many, million frames per second will you consume, um, right, by age whatever. And so, but the whale, the thing is that a human's input set, that data set that's collected, is just like, I would suspect astronomically more interesting than a whale's. Like, there's just, if it has a larger brain, like it doesn't have the training data that it needs, because it's, a model is great, right? And so the architecture of the brain as like a generic, you know, model for learning is great, but it's about the input data, right? And how fast can you get that brain the input data, right? Because the faster that you can get this brain new input data, the faster it can learn. Um, and so effectively, you know, yeah, I mean, effectively, and this is like the chaos metric, right? In the doc, we talk about the chaos metric, and the chaos metric is this idea that, like, if nothing interesting is happening, and this is like the system. There's another thing about the system requires entropy, right? So if nothing interesting is happening, um, there if nothing interesting is happening, there's no like that brain, the brain that is the entity, which is Alice, which is all these models and strategic plans that are learning, doing this active learning. Um, it they Yeah, I mean, they need interesting input data. You garbage in, garbage out. So anyways, so basically, yeah, I think AKA, unfortunately, we put it right below a data set. It just, oof, it just feels really. Um, it's just so it's so so something to reduce it to a data set. Um, states of consciousness. Um, Well, fuck it. I guess that's what they are. So it's all a data set to Alice, right? Because we have this representation where everything is basically data. Um, okay, so AKA, so I'm going to write it here anyways. AKA states of consciousness. Yeah. Okay. But we're supposed to be implementing stuff right now. So why were we here? Because we're arguing that everything needs a parent. Okay, so do, 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 everything needs, and a parent is a very general term. Basically, you have to tell me something about where you came from because I don't know what to do with you. I have no trust in random shit that flies around the internet. Like, and neither should anybody else. And Alice will definitely not, right? That's a no from me. So, and I think from the rest of us as well, right? So, she's going to be hypercritical and um, she's going to say, you know, where did you get this information? Okay, okay, information which landed on my doorstep. Where the hell did you come from, right? And can I trust you, or you know, and yeah, and do I need to, you know, maybe do I don't need to trust you, right? But I need to know something about it, right? So maybe you know we know something about it because it is a DID method and it signifies that it was the output of some, let's go back to our async for events in Alice. Um, we say, where was that? Async for event in Alice. We say async for, ah, mm, that's, that's what it should be. Async for thought in Alice. Okay, we're going to hear all of Alice's thoughts and we're going to print them right here on line 327. This is perfect. Okay, so perfect. Oh, this is great. Okay, so, but, so thought comes in. Maybe I should use this input data in one of my strategic plans, says Alice. I just scraped the web and found it. Okay, well, um, where did it come from, Alice? I mean, what you scraped the web, that's very generic. Tell me where you got that piece of input data from before you know, I don't know, go train my dog feeding model on it, right? You're saying that Ruffles should get you found a new article. Alice found a new article online. We wake up in the morning and we say, Alice, you know, what have you been thinking about? And she says, well, you know, I heard that on the World Wide Web that as she was off searching, you know, throughout the night, and she might say, well, I heard on the World Wide Web that Ruffles, he should actually be eating half the amount of food that you're giving him. Oh, well, Alice, I mean that. What's the likelihood that that's going to, you know, make Ruffles way too skinny? Um, well, okay, so she should have run that as well, right? But maybe she doesn't know that, right? So maybe she's like, I just found this. Maybe we haven't added that logic yet, right? She's just saying, I found this article on the internet. I thought you might like it, right? Um, but we know right off the bat that we don't like this thing if it doesn't have some kind of. So maybe this is like maybe one of the default overlays we have applied, which is this trust flow, right? And so um, this basically like don't deal with any information that I don't have X degree of trust on, right? And this is going to be basically something where we filter by origin. I think in the input origin. So we also need to know the origin. Okay. So yeah, so the parents is, it's not really parents. Parents is not really the right word. It's links or associations. It's links or association. It's just associations, but that's a terribly long word. Link. They're links. They're links. They're links. Yeah, they're links. It's a chain. They're links. Perfect. Okay, so they're links. Oh, I got another bing. Yes. Okay. Um, so they're links. Uh, okay, so let's go play with the system context. Where is it? Bing. Okay, so let's go mess with the system context. So let's make this links. Yeah. Okay. So it's not, nothing is direct ascendant, descendant. We're just saying here's some links, you know. You want to figure it out, you go figure it out. Go talk to these links, right? I'm just telling you, I'm somehow, for some reason, I think this might be related to me, right? That's all links does, right? So this says okay, so basically what we're going to end up here, which is a DID method, system context. System context will have links, which is other DIDs. Um, it will have upstream, it will have overlay, and it will have orchestrator. And those will be open architecture, or wait a minute. No, those will themselves be system context. Yeah, those will themselves be system context. Yes. Okay, yes, those will themselves be system context, and they will link to the parent object, which is the system context. Okay. Da, da, da. Okay, so if we have a top level system context, a top level system context has links set to none, right? Sorry, can't give you any information about where I came from, but here's a system context for you, right? You can decide if you want to deal with that or not, right? So if you are, for example, if we were thinking of a system context which represents a, uh, which represents, it would be nice to have some way to access static data, to declare and access static data. How could we declare and access static data? How do we declare and access static data? We can just traverse operations. Yeah, if we see an operation in there. Yeah, if we see a static data operation in there, we can traverse them based on their keys. Okay. Or maybe we can just traverse the inputs. Yeah, but it would be nice to call specifically like that one. What was that one? Oh yeah, I wanted to know the name, right? So if it wants to know the name, it reaches into the links and it says, we're in the Okay, we're in a downstream system context. Top level system context. Top level system context is top level system context CLI. Top level system context CLI. Where are we? Where are we? Where are we? Okay. System context links. None. Upstream overlay orchestrator. Okay, where are we? We want the entry point load name. Why do we want the entry point load name? Because we're over here and we want to add it to the namespace and we're not sure what its name is within this context. But the, okay, we're not sure what its name is in this context. We just need, this is dumb. Uh, this is super dumb. Um, okay, this is fantastic. Okay, this was really dumb. I think I did it again. I think I did it again. All we need to do is just change the code because it's right here. Um, okay, so this would just have a different load method which returns the name. Um, imagine that. I feel like I lost something here. I'm not sure what it was. We'll just pop back our stack and see how far we can go. So I think, what did we learn? Well, everything is the system context. The system context doesn't have parents, it has links. The system context is a DID method. The system context takes, the system context holds links, the upstream, the overlay, and the orchestrator, which are themselves system contexts, which will have in their links the parent system context, which is in that case a parent. Um, and how are we going to use this information? Well, we're going to load those system contexts, and then uh, we're going to call a method on them. So basically, we load the system context, and we say, and then what do we do? What do we do? What do we do? So we call a static function, or not a static function. Yeah, I mean, it's a function. So we call a function which takes a system context and produces an appropriate Python callable. So where is that code? So there is some code. Where is it? So take system. Okay, so basically, all right, so we'll just make that load ticked, and then we'll have the name, and then we'll say set atter sys. I'll just name sys ctx callable. Okay, as callable. When this thing is nude, with underscore underscore new underscore underscore, when that happens, then we can, how are we creating a derived system context? Well, we're really just modifying the config. System context is really just a class around the config, which is a DID method. So we're modifying the config. We're modifying the config content config. Where's that code? Where did it go? Where did it go? Where did it go? I think it's over here. Where do we do that? It's like the subclass. Config is default for subclass. Config is default for lambda is default for subclass. Installed overlays. Let's just pass this a lambda. Default directory for subclass is itself config upstream. Okay, and then overlays becomes system config becomes these went inputs can be added to overlays. This became overlay, which is itself system context. So is it a system context or is it a system context config? It's just a system context config. And this orchestrator is also a system context config. Okay, so these are effectively, we can say data flow. So for now, we'll take a data flow. Upstream. Okay, so upstream overlay orchestrator. Okay. Data flow, okay, so. Okay, so, and in the future, what we'll do, so what we're saying now is, so these, okay, the following, we will, okay, no, we're just going to do system context config. No, I was gonna like, I don't, we're in the middle of doing this. We're not gonna, no, we're gonna do it. We're gonna finish it. Okay, so system context config. Oh, wow, it's everywhere already. Okay, look at that. So it's the upstream. Nope, it's the links, which is what? More system context config. No, these are what? Mm-hmm. 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 Okay. Okay. So remember, we should not put the DID in the document itself because obviously it's signing. I mean, it's not going to work, right? So we can create a link, and then we can put the DID of the link, and then we can put we can put the so what that's how we'll do it. Basically, we'd go hop hop hop, right? So they don't have each. Do they have each other? They're pure DIDs. They're just pure DIDs. What? No. What is this? Thanks. No. Yeah, this thing just doesn't know. This thing doesn't know what it's called. It doesn't know what its ID is. It can figure out its ID by traversing the links. If you asked it, it could figure out its ID. basically. If you ran a flow in this, if you applied the overlay to the upstream, ran the flow with the orchestrator, if you use the orchestrator to apply the overlay to the upstream and ran it, and you ran a flow which was get your DID, then this thing could traverse links had you put it in there. Okay. And we should pass the overlay. When we run the overlay, we should pass it the system context. When we run the overlay, we should pass the system context / system context config. Okay. And that way the overlay can have the ability to, make the data flow use it if the data flow wants. Or if we decide the data flow needs it, right? So the orchestrator, okay. Thanks, Upstream Overlay Orchestrator. This has been fantastic. Okay. It was truly Eureka. I didn't realize, I thought, is this still going? We are still going. I didn't realize how exciting this was going to be. Okay. And so what was that? We had so this thing, no one reads to-dos, not at least me. So I'm just going to raise an error. I'm putting the to-dos in there because I might read them, but I mean, hopefully I do, right? So these are, they're running thinking is the problem with the to-do statements, and then you don't remember to go back and update them as you're doing this. So I don't really love the to-do thing. I don't think it should be in the code. Should it be in the code? It should be, Alice should tell us when Alice can tell us when the to-do is not aligned with the current state-of-the-art train of thought. That would be great. And then she can just go through and delete them. Fantastic. All right. And she'll archive them, obviously, as well. So even when we're like this, because remember, we're creating these links, we're creating this chain of everything. So even though we're just working in memory right now, she'll still have all this. Can you tell I've lost my work one too many times? Okay. Not implemented here. Oh, yeah. Okay, so need to do, now see here, I'll read the to do. Call, call past right. I guess I'm just doing it now. There's no reason to do this. There's no reason to do this. Thing with the lambda here. There's no reason for that. Because this thing, That's the whole fields. So just don't do that. All right, this is fine because we're actually passing this thing in as an argument and we want it to be that class's instance. We don't want to create a new instance on the fly. That is the instance for that class. Um, okay. 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 This is as callable. Okay. It optionally takes links. All right. So what is this? It's a union of, it's just basically any. What are those? As callable. Deployment environment. All right, so as callable for this deployment environment, right? So default, okay, let's go. Okay, all right, okay. Hmm. But what about, that's even cleaner. Async forethought and Alice, no call. That's even cleaner. So we could just say, yeah, as callable, or maybe as Python native. Yeah, there we go. And we'll say and we won't pass anything, which means give me the default flow. Or wait a minute. Deployment Python. Oh, there we go. Deployment. Okay. I tell you one thing about the environment that you're in. If you don't know what to do with that thing, then you run your default flow. No, then you can provide an unknown flow. Or no, you run the default flow. No, if you don't know what deployment, okay. So if you don't have a deployment environment, yeah, it's going to end up just running the default flow. Okay, so in the event, the deployment environment requested was not found, aka an auto start or operation when condition sysctx.unknown.deployment string sysctx.unknown.deployment is present as an input. Okay, wait a minute. No, I just combined two things. Okay, so in the event deployment requested is not found, aka okay, so if you don't give anything, if there's nothing there, okay, in the event the deployment environment requested was not found, aka there's no auto start operation. There's no operation which takes, okay, there's no, aka there is no operation within the system or within the flow. After or before deployment. Okay, deployment Python. Do we need to run the overlay to understand the deployment environments? Not necessarily. Not necessarily because of this. So we could have an overlay which adds support for a new environment, and the way that it adds support for a new environment is by overlaying a output operation which accepts string.sysctx.unknown.deployment or .deployment.unknown. Okay, so it could accept this deployment unknown, and it could then kick off. So we say So then we'd run the default flow, right? So deployment Python. Okay, so deployment Python doesn't exist. In that case, deployment, okay, if, so if okay, what do we want? Oh, it's tricky when it's not all on the same screen. Okay. Deployment Python. It says ctx.deployment Python. So what does that say? We want to turn this thing into a async for loop just by importing it. We want to know Alice's thoughts just by trying, just by asking, just by iterating with no input. So as soon as we start to iterate, async for thought in Alice, what is she going to do? So where's that code? DFML source wrapper. Okay, the wrapper source. Here. This handles no, where did that go? Context managed wrapper source. No, there's one with way more. Here it is. Okay, so I'm gonna put C for arbitrary wrapper func slash coroutine slash generator wrapper. Covered in recording in engineering log. Boop, boop, boop. So we had deleted it. That's why it was not there. I don't know if this got moved somewhere else. I don't think so because we searched for a wrapper. Yeah, so it would have showed up. Okay, yeah, that's what I grepped for first was this class, but it was not there. So Wrap with functionals. Okay. So this will grab us any old function. Let's see if we can get this all in my frame here. Boop. Where'd it go? Oh yeah, this was funny. We realized cache down that did not have to be a decorator after all. There was really no reason for that. Okay. But why is this code relevant right now? This is an arbitrary thing. Okay, so this code will be helpful to us when we go to, we'll probably modify op to use some of this stuff. And then everything is the system context. Everything has links, not parents. So we don't want everything to have a link. We don't want everything to have a parent. We just, we don't want everything to have a link, but it would be great if you did. Okay, so, all right, I'm gonna take a break. But I think we're close on this deployment thing. There's some kind of way where this is gonna end up spitting out a class.